Right, quantitative analysis, chapter 11. Um, so let's dive in. I think as we walk through this, I think we'll be able to tackle some of the core issues there. And of course, as usual, please do all the related questions and get used to that. But let's jump in and see what we have. Right. So we're starting off with the Hilo method. So they start this discussion, talking about the Hilo. Oh, sorry, it says chapter 9 here. Well, my slides are slightly, of course, old. It's exactly the same thing, but my slides are slightly with the line to the old, the previous book, last year's book. Anyway, chapter 11. So first of all, I guess this business of Hilo method here can be used to analyze any curves that have this type of appearance where there seems to be a regular uniform growth, if you like, in whatever variable, in whatever independent variable we're talking about as a result of some kind of, well, independent variable as a result of an increase in an independent variable. So for example, if I'm making more units, we know that variable costs, the behavior of variable costs, right, are to increase with each additional unit. So I'm just starting from here because generally we assume, well, most organizations will have a type of fixed cost that they have to accept whether or not they're making units or not. And really, if I'm making one unit, really the additional cost, so to speak, imagine that was £5. Well, when I say 5, imagine this is 50, so this would be 55. So really, I'm just saying that the variable cost as a result of one unit is £5. And then when I go here, you would notice that this would be 60. So when there is some sort of constant increase, if you like, in your variable cost as a result of an increase in the unit. So really, I'm kind of, again, coming back to this idea of marginal revenue and marginal cost. And so typically what you don't have, the information you don't have is that 5, you see, because I'm looking for that 5. I don't have it. So I mean, really, that's 1, 2, and that's 3. So technically, I could just simply say, well, 60 minus 55 divided by 2 minus 1. And that would get the 5 over 1. And that's how I would get my 5. But you typically don't have information that's that close. So what you might have, I mean, it's the same principle. I mean, I could have said, right, this is 65 and this is 3. I could have then said 65 minus 55 over 3 minus 1, and that would have been 10 over 2, and that's 5. So you can see that it doesn't really matter where I go. The point is that as long as this assumption of constant change with every unit is true, I can find the change. That's the key word, the change. And that's really the thing I'm looking for. Now, the nature of this curve, let me just kind of go on a little. So again, like this is, again, usually, as you know, I talk in the slides kind of hopefully marry into it as I carry on. But the fixed and variable cost can then be used to forecast the total cost of any level of activity. So that curve you just saw me draw, really, right, is the curve total cost is equal to fixed costs plus variable cost, where you see me holding very fixed costs over here and my variable cost kind of increases. And I can then see, like I said, I had 50, for example, then I had 55, and then I had 60. So my total cost, of course, is here would have been 50 plus 5. And then I'm just going up this way, and this is me recording my total cost, but this is composed of my fixed cost and my variable cost. And you can see this is a set number. It's just what it is. It's not changing. So whatever the variable cost is, that's fixed. And that's what's changing with units as a result of that change. So this curve can evolve into total costs. I could call this Y because this is on the Y-axis, isn't it? Total cost is equal to A, and I can call this A and give it an actual whatever figure, it's a fixed figure, plus this change 5 times my number of units. So for example, I'll call that change B, and I'll call my number of units X. So for example, remember where I had total cost, I'm just making this up so you can sort of see where I'm going, where 50 was my total cost, I had fixed cost and I had no units. So B times 0, so everything was 50, right? So that was just 0, all of this. Now remember with the first unit, I would have had 55 is equal to 50 plus 5 times 1, where I'm talking about I have 1 unit, the variable cost is 5, and you can see this growing into this kind of 50 is equal to 5 times 2. And all I'm trying to do is to be able to plot a curve so that I could almost pick if you like, or extrapolate and make assumptions, because I know if I know the fixed costs and I know the number of units involved, if I know the variable costs, I can then assume a number of units and say, what would it be like if I had 100 units? Well, I would say, well, that would be, if you like, that would be 50 fixed cost plus 5 times 100 units, and I would get my total cost. And that's really what we're trying to do here. So the curve really is this y is equal to a plus bx. And most of the time you're trying to find out what that change is, because once you know what the change is and you know what the fixed costs are, you can always extrapolate and make assumptions about anything else happening. So the fixed and variable cost can then be used to forecast the total cost at any level. So typically, how do I then get to that change? And so what and I have a feeling we must have looked at this in a bit of pricing. I think we did this in pricing, but they're making us do it again, but that's fine. We select the highest and the lowest activity levels, because typically these costs are driven by activity. And I mean, I make a note that it's not about the highest and lowest costs, it's about what's driving the costs. Take the highest and lowest activity levels and their associated costs. And then you calculate the variable cost per unit. Of course, to calculate variable cost per unit, we then look at, if you like, we then sort of do what's referred to as the Hilo method and really look for that change. I've been doing it already, haven't I? When I said 60 minus 50 divided by 3 minus 1. This is, in that case, that was my sort of high cost, and that was my lower cost, and that was in terms of cost, and those were my high units, and those are my low units, the related units. And I was able to find that 5 figure that I was looking for. And then, of course, again, once I've done that sort of kind of thing where I've taken the highest and the lowest, and you can see I've taken the highest and the lowest because, well, typically this is a curve that passes through a number of points, so to speak. It's never quite perfect, but at least I know if I've taken the highest and the lowest activity, I'm most likely to get the best average variable cost. When I say variable cost, variable movement as I go along, if you like, which is why we always take the highest and the lowest units to do this, and their associated costs. Right. And then once I found that, I can then do a few things, and I can play around. With it. Again, like you see me here, I highlight that the assumptions are typically, of course, this is this idea of having a fixed cost here and having this variable business going on here is referred. Typically, this is a semi-variable. This is a semi-variable cost, right? And so typically the linear model here is what we accept. Y is equal to a plus b, y is equal to a plus bx. So some of the advantages: it is simple, quite easy to understand and use, but we are assuming a number of things, that this cost is constant, so to speak. The variable costs do not change, which is why we now move into the next topic later on today. It assumes that historical costs reliably predict future costs. We're literally just sticking with that single change. And the assumption that this is all purely due to activity is another thing. But they are variable costs, so it's not a poor assumption. And it only uses the two values, the highest and the lowest. So I mean, this is just being simple, being straightforward. There are other methods, but not on our syllabus. There's algebraic methods. We can use graphs as well. But again, really, I think it's just having some kind of appreciation. Right, so let's do this example and then we'll take a break. So you have a scenario, I mean, and I suggest what you should do from time to time, I think, is to plot the thing yourself and just sort of get a feel for what's going on here. So I'm just going to make my plot over here. And you can see here my units will be along this line, right? And my costs will be on this line. So you literally, if you have all your units here and all your inspection costs here, and these are your total costs, right? All plotted along this line. And you can then just plot the graph. So what I'm just going to do, just for simplicity, is I'm just going to find what the lowest number of units are, and that's 300, and what the highest number of units are, which is 420, I can see there. So I'm just going to put the 300 here, call it 300, and its associated cost I'm just going to call, I'm just going to start from here, and I'm just going to call that 2160, and just kind of pull that up a little and then do that over here and call this 420 and then call this 2400. So really, everything I've been doing so far, you saw me do the change. Really, so really asking is that I'm trying to say, well, I'm trying to really find what happens when activity increases by 1 unit. That's my goal. And so I do that by asking, well, I can do that. I can almost assume this is, let's see what the change is, what the change in cost is over this medium here. So really what I'm saying is 2,400 minus 2,160 divided by 420 minus 300, right? Let's just quickly ping that out. Ping that out very quickly. Okay. So you have 2,400 minus 2,160, which is 240, divided by 120, and you can see that your variable cost is £2. And now, I mean, I'm all right now, because now that I know what my variable cost is, that's what they're asking for. I mean, I know that y is equal to a plus bx. Doesn't really matter. I will go with I suggest you go with the highest or the lowest, because then that's what you actually picked, you see, to make your curve. It's possible some others might align, but many of these other items might just be off the curve, if you like, because, you know, there's a mixture of fixed and variable in there. They might just be, they shouldn't be, but they might be. So I'll pick the 300, doesn't matter. So what's happening here is that the total cost at 300 is 2,160. So we're saying 2,160 is equal to this fixed cost, which I don't know, which is what I'm trying to find out, plus variable cost is 2 times, of course, the number of units, and that's 300. And so I have 2,160 is equal to A plus 600, and therefore A is equal to 2,160 minus 600. A is equal to 2,160 minus 600, and that leaves us at 1,560. So that's the total fixed cost. So now I have my equation very clear. Y is equal to 1,560 plus 2x. This will hold. That's my assumption, which means I could extrapolate. I can say, well, what's going on when I have 500 units, which is what they're asking. If I have 500 units, therefore y is equal to 1,560 plus 2 times 500, which is y is equal to 1,560 plus 1,000, which is 2,560. So my total cost at 500 units, I can slip that in there, is 2,560. Awesome. Great stuff. See you in the next video.